Hey everyone, ready for a deep dive into the world of explainable AI? We're basically talking about making AI's decision-making processes transparent, understandable to us humans.
It's like, yeah, shining a light into the black box of AI, so we're not just blindly trusting it.
That's a great way to put it. And it's
Huh.
super important in fields like healthcare, finance,
Yep.
robotics, where AI is making decisions that have a real impact on our lives.
You're absolutely right. The stakes are high and trust is paramount.
Couldn't agree more.
Our deep dive today is based on a research paper titled Explainable Artificial Intelligence, XAI, From Inherent Explainability to Large Language Models.
And one thing that really stood out to me was this idea that more complex AI models aren't always better.
Right.
There's this trade-off between accuracy and explainability.
That's a really key point.
Yeah.
Think of it like this. Some AI models, like linear models or decision trees, are inherently interpretable.
Oh, okay.
Their structure is simple enough that we can easily follow the logic of their decisions.
So it's like choosing between a straightforward instruction manual
Yeah.
and a complex piece of code.
Yeah, exactly.
Okay.
But those simpler models, they might not always be the most accurate for complex tasks, right?
Yeah.
Then you have the black box models, like deep neural networks, which can be incredibly accurate, but notoriously difficult to understand.
Yeah. The research paper actually visualizes this trade-off, showing how simpler models are easier to grasp, but might be less accurate, while complex models can achieve higher accuracy,
Right.
but at the cost of transparency.
Yeah, it's like having a super talented chef who can create an amazing dish, but they won't share the recipe.
Oh, I like that.
You get delicious results, but you can't really learn from the process.
Right. So that brings us to the heart of XAI, right?
Yeah.
How do we open up those black boxes and understand the reasoning behind those complex models?
That's the million-dollar question. There are a few different approaches, but let's start with one of the most common ones, attribution-based methods. Imagine an AI is classifying images. Let's say it's looking at a picture of a bird and identifying it as a robin.
Okay, yeah, I can picture that.
An attribution map could highlight which parts of the image were most important for the AI to make that decision.
Yeah.
It might highlight the bird's beak shape, or its wing pattern, or maybe even its posture.
So it's like the AI is saying, see, I'm not just randomly guessing, I'm focusing on these specific details to make my decision. It's like showing its work.
Exactly. It's providing evidence for its reasoning.
Are there other ways to get these explanations?
Absolutely. We also have example-based methods, which use simpler models or examples to try to approximate the behavior of the complex model.
Got it. So instead of trying to decipher the entire complex system, we're looking for simpler, more familiar patterns that we can understand.
Right, you got it.
Makes sense.
Mhm.
Are there any other methods in this XAI toolkit? What else can we use?
Definitely. Another interesting one is attention-based methods. They leverage attention mechanisms, which are kind of like the AI focusing its eyes on specific parts of the input.
Oh, so if it's reading text, it might linger on certain keywords or phrases.
Exactly. And by analyzing what the AI is paying attention to, we can gain insights into its decision-making process.
Oh, that's really cool.
Then we have counterfactual explanations, which provide what-if scenarios.
What if scenarios? That sounds intriguing.
Like, imagine you applied for a loan and were rejected. Right. A counterfactual explanation might tell you something like, if your credit score had been 50 points higher, your application would have been approved.
Whoa, that's super helpful.
Yeah.
It's not just telling you what happened, it's giving you specific actions you could take to change the outcome. It's like personalized advice from the AI.
Precisely. It's about understanding not just the decision itself, but the factors that led to it.
I'm really liking these counterfactual explanations.
Yeah, they can be really powerful.
But while all these methods are really promising for understanding black box models, it's important to remember that we're still in the early stages of XAI, right?
Absolutely, we are.
So there are still challenges and limitations to overcome.
Of course. One of the key challenges is ensuring that the explanations we get are faithful.
Faithful.
Meaning, do they accurately reflect how the AI is actually making its decisions? There's a lot of research going on in this area to develop robust methods to evaluate the faithfulness of these explanations.
Makes sense. It's like with any new scientific field, there's a process of refining our tools and methods to make sure they're reliable.
It's all part of the journey.
Yeah. But even with these challenges, the progress being made in explaining these complex models is exciting.
I agree. It's a rapidly evolving field.
And it's not just limited to those traditional black box models, right?
No, not at all.
One of the most exciting areas of XAI research right now is focused on large language models, or LLMs.
Oh, absolutely.
Oh, yeah. LLMs like ChatGPT are all over the news these days.
For good reason.
And for good reason. They're capable of generating human-like text, composing everything from poems to code. It's amazing.
It's mind-blowing, really.
But I have to admit, I've often wondered, how they do it. What's going on under the hood?
It's a question many researchers are grappling with.
Yeah.
LLMs are incredibly powerful, but their reasoning processes can be quite complex and difficult to understand.
So are we just supposed to trust that these LLMs are working correctly, even if we don't fully understand how?
Well, not necessarily.
Yeah.
Researchers are actively working on methods to make these LLMs more explainable.
Okay, good to know.
Some of the techniques we've already discussed, like attention-based methods, can be applied to LLMs.
Okay.
But there are also unique challenges when it comes to explaining LLMs.
Like what? What makes LLMs so different?
Well, for one thing, LLMs typically deal with text data, which is discrete, meaning it's made up of individual words.
Okay.
This makes it trickier to apply certain mathematical techniques that are commonly used to explain models that work with continuous data, like images.
So it's like the difference between analyzing a smooth curve and a staircase.
That's a great analogy.
Yeah.
With a curve, you can easily measure the slope at any point, but with a staircase, you have these discrete jumps.
Right.
Another challenge is that LLMs are often trained on massive amounts of data, which can lead to what's called gradient saturation.
Gradient saturation.
This means that the signals we use to understand which input features are important can become very faint and hard to detect.
It's like trying to find a whisper in a hurricane.
That's a very vivid way to put it.
So how do researchers deal with these challenges? How do we start to make sense of these incredibly complex LLMs?
Well, there are a few different approaches being explored.
What?
One is to develop specialized techniques that are tailored to the specific characteristics of text data and LLMs.
Right, makes sense.
For example, researchers are using methods like integrated gradients, which help to smooth out those gradients and make them more reliable.
So it's like finding a way to amplify that whisper in the hurricane so we can actually hear what it's saying.
Exactly. We're trying to make those signals stronger and clearer.
Are there any other approaches being used to explain these LLMs?
Yes. There's a lot of interest in using model-agnostic techniques like LIME and SHEP.
Okay.
The advantage of these methods is that they don't rely on knowing the specific details of how the LLM works internally.
Right.
Instead, they work by perturbing the input.
Perturbing.
For example, by removing or replacing words
Okay.
and seeing how the output changes.
So it's like running little experiments on the LLM.
Exactly.
Like what happens if we change this word? Does the output change significantly? And if it does, that must mean this word was really important for the LLM's decision-making.
You got it. And by analyzing these changes, we can start to build a picture of how the LLM is processing language and making decisions.
That's fascinating. It sounds like there are a lot of creative approaches being used to unlock the secrets of these LLMs.
Oh, absolutely. It's a very active area of research.
But let's get back to those attention mechanisms we talked about earlier.
All right.
You mentioned that they can also be used to explain LLMs. How does that work?
Remember, attention mechanisms allow the LLM to focus on specific parts of the input text when generating output by analyzing the attention weights.
Attention weights.
Basically, how much attention the LLM is paying to each word.
Got it.
We can gain insights into which words or phrases are most influential in shaping its response.
So it's like watching the LLM read through a text and seeing which words it highlights or underlines.
Right.
Like it's showing us what it considers to be the most important parts of the text.
You got it. And this type of analysis can reveal a lot about how LLMs understand language, context, and even things like sentiment and tone.
It's like getting a glimpse into the mind of the LLM.
In a way, yes.
But with all this talk about LLMs, I'm curious, how does explainable AI apply to other areas of AI, like robotics?
Oh, that's a great question.
Like how do those two things connect?
Explainable AI is becoming increasingly important in robotics, especially as robots become more autonomous and start interacting with humans in more complex environments.
Makes sense. If a robot is going to be working alongside humans, we need to be able to understand its decisions and make sure it's behaving safely and predictably.
Absolutely. Imagine a robot working in a warehouse alongside human workers.
Yeah.
If the robot suddenly makes an unexpected movement, we need to know why.
Right. Like what triggered that?
Was it a malfunction? Did it misinterpret a command? Or did it perceive a safety hazard?
Those are high-stakes situations. So how do we apply XAI to robots?
Many of the methods we've already discussed, like attribution methods and counterfactual explanations, can be adapted for robotics.
Oh, okay.
For example, attribution methods can be used to understand which sensor inputs the robot is relying on when making a decision.
So if a robot is navigating a crowded room, we could see whether it's primarily relying on its vision sensors, its proximity sensors, or some combination of both.
Exactly. We can see what information it's prioritizing.
That's really cool.
And counterfactual explanations can be very useful for debugging robot behavior.
Okay.
Let's say a robot arm is trying to grasp an object but fails.
Yeah.
A counterfactual explanation might tell us, if the gripper had been open 2 centimeters wider, the robot would have successfully grasped the object.
That's incredibly helpful information for, improving the robot's design or programming.
Exactly. It helps us understand the what-ifs and make adjustments accordingly.
It's like giving the robot a chance to learn from its mistakes.
In a way, yes, we can use these explanations to refine its behavior.
But before we move on, I want to touch on another area where XAI is having a major impact. Healthcare. Oh, absolutely. Healthcare is a prime example.
It's easy to see why explainability is so crucial in those situations.
Right.
Doctors and patients need to be able to trust the AI's recommendations and understand the reasoning behind them. We're talking about people's lives and well-being here.
Absolutely. The stakes are incredibly high in healthcare. Imagine an AI system that analyzes medical images to detect signs of cancer.
Yeah, that's a great example.
A doctor would need to know why the AI flagged a particular area as suspicious.
Right. They can't just act on a blind recommendation.
What features in the image led to that conclusion?
Exactly. The doctor needs to understand the AI's reasoning process.
It's essential information for the doctor to be able to make an informed decision. It's not enough for the AI to just say, I think this is cancer. It needs to be able to explain its reasoning.
Right. It's about providing evidence and justification for its conclusions.
And in situations where an AI is recommending a particular treatment plan, both the doctor and the patient would want to understand why that plan was chosen, right? What factors did the AI take into account? What are the potential risks and benefits?
Absolutely. These are crucial questions that need to be addressed.
These are questions that go beyond just the what of the AI's decision.
Yeah,
They get to the why, the reasoning, and the justification.
exactly. It's about transparency and accountability.
And that's where XAI comes in.
Right. XAI provides the tools to answer those why questions.
So how is XAI being applied in these healthcare scenarios? What are some concrete examples?
One example is using attribution methods to highlight the areas of a medical image that are most important for the AI's diagnosis.
Okay.
This can help doctors quickly focus on the relevant information and make faster, more accurate assessments.
It's like having an AI assistant that points out the key details in a complex medical image.
Right. It's about augmenting human expertise, not replacing it.
It's not replacing the doctor's expertise, but it's helping them to make more informed decisions.
Exactly. It's about collaboration between humans and AI.
I like that. And another example is using counterfactual explanations to help understand how changes in a patient's medical history or lifestyle factors might affect their risk of developing a certain disease.
That's a great example. It's about personalized medicine and empowering patients to make informed decisions about their health.
So it's like giving patients personalized insights into their health and empowering them to make proactive choices.
Exactly. It's about moving from reactive to proactive healthcare.
But with all these potential benefits, are there any challenges to implementing XAI in healthcare? I imagine there must be some hurdles.
Of course, there are always challenges when implementing new technologies, especially in a field as complex as healthcare.
Right.
One challenge is ensuring that the explanations provided by these XAI systems are actually understandable to medical professionals who may not be experts in AI.
Yeah, that makes sense. It's like translating between two different languages.
Exactly.
The language of medicine and the language of AI.
We need to make sure that the explanations are clear, concise, and relevant to the doctor's needs.
We need to bridge that gap so that everyone can benefit from the power of XAI.
Absolutely. It's about making XAI accessible and user-friendly for everyone involved.
Another challenge is making sure that these XAI systems comply with all the relevant privacy regulations, especially when dealing with sensitive patient data.
That's a crucial consideration. Data privacy is paramount, especially in healthcare.
We need to be able to explain the AI's decisions without compromising patient confidentiality.
Right. It's a delicate balance between transparency and privacy.
That's a really important consideration. We need to strike a balance between transparency and privacy.
Absolutely. It's an ongoing discussion, and researchers are actively working on solutions that address both of these crucial aspects.
But it sounds like there's a lot of effort being put into addressing these challenges and making XAI a valuable tool for both doctors and patients.
I agree. There's a lot of enthusiasm and momentum in this area, and I'm excited to see what the future holds for XAI in healthcare.
That's a really inspiring vision for the future of healthcare.
It is. It's about leveraging the power of AI to improve patient care and outcomes.
But before we get too carried away, let's take a quick break.
Sounds good.
When we come back, we'll continue our deep dive into explainable AI,
Okay.
exploring even more fascinating concepts and applications.
I'm looking forward to it.
Stay tuned.
All right.